A hydrogen fuel cell runs vehicles and other machines by directly converting the chemical energy in hydrogen gas into electrical power. Hydrogen is an abundant fuel source. It can be extracted from water, enabling almost any country to produce it domestically. Hydrogen fuel cell engines can power vehicles and run backup generators for large computer operations. They produce electrical power without any emissions. At the heart of the engine is a stack of super-thin hydrogen fuel cells. The engine's blower blows in air. The fuel tank feeds in hydrogen gas. Hydrogen and oxygen react and create electricity. Each fuel cell is made of 5 parts. On each end, there's a channeled plate made primarily of carbon, a material which conducts electricity. Hydrogen enters the cell through the first plate, which channels it through the next component, a chemically treated paper, which conducts both gas and electricity. Then the hydrogen enters this membrane, where it splits into protons and electrons. The protons react with the drawn-in oxygen, producing water. The water passes through another paper to the cell's outer plate, where a pump draws it away. Meanwhile, the electrons travel to the end of the stack of fuel cells to electrical wires. After assembling the stack, technicians compress the fuel cells in a hydraulic press. Compression helps the current flow smoothly from cell to cell. It also presses the rubber gasket around each plate to the adjacent one, sealing the stack so that hydrogen can't leak out. The technicians run a quality control test with nitrogen gas to verify the seal. Before releasing the press, they install high-strength steel rods to bind the compressed cells together. For a stack this size, the rods apply 3 tons of pressure. With the stack now off the press, they hook up an electronic circuit board which monitors the voltage of each fuel cell. After securing the connectors to the stack with an adhesive strip, it's just a matter of connecting one to each fuel cell and securing that connection with a special type of epoxy which contains silver to conduct electricity. Next, they mount the circuit board and a plastic cover to protect it. The fuel cell stack is now fully assembled and moves to the factory's test area. A technologist mounts it on a test station and, simulating installation in an engine, hooks up a hydrogen line, an air line, and a water line for cooling. The testing machine runs a 3-hour automated performance test. They mount the stack onto the engine's structural frame, then install the hydrogen recirculation pump. Next, a water recirculation pump, which cools the fuel cell by pumping in cool water. Then they mount the components which feed hydrogen stored at high pressure in the fuel tank. That pressure pushes the gas through stainless steel fuel lines to the cell. Next, the fan, which blows outside air into the fuel cell to react with the hydrogen. This filter removes dust and other contaminants from the air the fan draws into the fuel cell. Meanwhile, technicians have assembled the computer which controls the whole engine. They now connect the wires from the fan, the pumps, and the other engine components to the computer. They hook up the fuel cell output wiring, the wires which carry the current the fuel cell creates, and sends it to whatever vehicle or device the engine is powering. A tiny portion of the cell's output runs the pumps and other engine components. Now fully assembled, the engine undergoes extensive performance and safety testing. Once it passes every test, technicians perform a final visual inspection, then install the sheet metal cover. The hydrogen fuel cell engine is now ready to be shipped to the customer and installed in the machine it'll be powering. Whether running a vehicle like this forklift or powering computer servers, the only byproduct is waste heat and water, which is why hydrogen power is clean energy.